Now we will simplify the following expressions. The idea here is that we are looking for factors that appear in both the numerator and denominator and can therefore be canceled. Here we have a y plus 3 times a y minus 1, and in the denominator we have a y plus 5 times a y minus 1. If we're dividing y minus 1 by y minus 1, that's really 0, or really 1, because y minus 1 divided by itself would just be 1. So now we are left with y plus 3 times 1, which doesn't change, and y plus 5 times 1, which doesn't change. So now we have y and y. The question is, can they be canceled? And the answer is no, because these are not factors, these are terms. We can only cancel factors. If this were 3 times y, or 3y, and this were 5 times y, or 5y, then we could cancel the y's. But since these are added or subtracted here, these are sums or differences, we cannot just cancel unless that factor of y appears in each term in the numerator and denominator, and it does not here. So this is the simplified form. Here we have to look to do the same thing, and that is to cancel like factors, but I don't see any factors here. But I do see a factor of 2 or negative 2 that is repeated, so I want to factor that out and see what that does. So since negative 2 goes into both negative 2x and negative 2y, I can factor it out, and my numerator is actually negative 2 times x plus y, negative 2x minus 2y, and my denominator is x plus y. And now, since I have an x plus y in the numerator and an x plus y in the denominator, I can cancel those, and then this would leave me with just negative 2. Now we will look to factor both the numerator and the denominator. I'm going to look for the greatest common factor here, which is 6. So I can take this out as 6 parentheses x minus 2, because 6 times x is 6x, and 6 times negative 2 is negative 12. Here I can factor out a 3 if I'd like. So I have 3 parentheses, and this would give me x squared minus 4, because 3 times x squared is 3x squared, and 3 times negative 4 is negative 12. Now you might think that you can just cancel the coefficients here, and then these two have to remain. However, this is the difference of two squares. So I know that I can factor this as well. So my numerator will stay as 6 parentheses x minus 2. My denominator, the 3 stays, and instead of x squared minus 4, I'm going to write x plus 2 times x minus 2, because I know that the difference of two squares factors into a sum and difference pattern with the square root of the first term and the square root of the second term separated by a positive and a negative sign. Now I have an x minus 2 in the numerator and an x minus 2 in the denominator, so they can cancel. And now I have a 6 divided by 3, which is a 2. So all I'm left with is a 2 over x plus 2. So in each of these, we're going to try to factor what we can before canceling it. We may need to factor the numerator independently of the denominator. We may need to factor both of them, and we may need to factor repeatedly until we can find common factors to cancel.